Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your Maths faculty. Let us move on to the today's class. So today very important topic is going to discussed. That is nothing but functions. Okay? Yeah. Let us say this. So before that we need to discuss about what is a set and their formation of nothing but how we are representing that set. Nothing but there are two different ways of sets we can have. Two different ways we can represent a set. Nothing but roster form or list form. And the second one is set builder form. Then we need to discuss about the relations. Then after we are going to discuss about what are the functions. How can we consider as a function. And before that we need to discuss about the Cartesian product also. So here we should discuss about what is set. Okay, na? We need to discuss about the set and the representation of set. Okay, so representation of a set. Next, Cartesian product. Then after, what is a relation? Then we can go through what is a function. Let us discuss about a set. Set is nothing but a collection of well-defined objects. Set is nothing but a collection of well-defined objects is called a set. What is well-defined? Well-defined means if you write some objects or entries or elements in a set, all the elements should follow some rule that is called well-defined set. For example, let me give you the clarity by taking an example. For example, all the stars in a sky. That means if you wanted to take all the stars from the sky, if I take and you take, the collection will be the same. Am I right? Yes. And if I give the statement like some stars in the sky, then the collections can be vary from you and me, because you might be like all the brighter ones, I might be like all the stars which can be lighted less, okay, not that much brighter. So your collection, the way of collecting the stars and my way of collecting the stars can be the different, because I have given that only the statement as some stars. If I give all the stars from the sky, we can collect in both the manners. According to you and me, the set of the elements must be elements in the set will be same. Okay. For example, the famous writers in India. If I give it one, write 10 famous writers in India. 10 famous writers means there are many type of writers. They can write poems well. They can write stories well. According to they can write the crime stories well, they can write the love stories well, like there's some different type of categories will be there, no? So but when I'm giving the statement, I did not mention any particular rule. If I give that write the famous top 10 crime writers, if I give the statement, you and my your collection, my collection can be the same, then the set can be the well defined collection. Then we can call that collection of set, collection of objects or collection of writers can be taken as a set. But here I did not mention anything. I just given the statement like collect top 10 writers in India. Top 10 writers means I did not given any criteria to collect the names. There are so many writers are there, so we did not give any criteria. So that cannot be a set. Now I hope you understand what is well-defined collection. Okay, right. All natural numbers. Set of all natural numbers. Yes, if you write you and me, our collection is definitely true, because all the natural numbers means 1, 2, 3, 4 and so on. That will be the true for everyone. So it can be the well-defined collection. So we can call it as a set. So simply the collection of elements or objects or entries which are having well-defined, the well-defined objects in a set or in a collection of a particular thing, that can be taken as a set. Okay. Now coming to the set of representation of set, there are two different types, nothing but roster form roster form or list form, and second one set builder form. Roster form or list form, and second one is set builder form. Roster form, if I wanted to write all the natural numbers up to all the natural numbers less than 10. Less than 10 natural numbers we want to write like 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the numbers, these are the natural numbers less than 10. There are 9. So same way, how we are representing in the set builder form? Set builder form, we are writing a numbers are in the form of x. This line we can call such that x belongs to natural numbers. X belongs to natural numbers and x less than 10. So this is called set builder form. That means if you wanted to write a set, the set are in the form of some elements. The elements are in the form of x. X we have to take in from the set of natural numbers. X belongs to capital N, and the x value is less than 10. So from the set of natural numbers, we need to take the numbers which are less than 10. So this is called set builder form, and it is called roster form. Okay. Now coming to subset. Subset are nothing but, for example, if you take, I am taking two sets like capital A and capital B. Set A having the elements 1, 2, 3, 4, and set B having the elements 2, 3. Then B is a subset of A. B is a subset of A. Actually, subset meaning is all the elements of set B are also the elements in set A. Then B is called subset of A. A is called superset of B. Okay. So here 2, 3. These 2, 3 elements are also in A. 2, 3. Therefore, B is subset of A. Okay. And there are lot of different type of sets will be there. Null set or there, singleton set, equal set, equivalent sets. So like so many some different type of sets are there, but right now we don't want all those things. So just you focus on what is subset. Okay, right. Now let us discuss about the Cartesian product. Cartesian product and ordered pair. Let us discuss about an ordered pair. That means if you wanted to take an ordered pair like in the form of x comma y. Order pair. This is called order pair. In this order pair, we have taken two elements. How many elements? There are two elements. The first element is called abscissa. First element is abscissa, and the second element is called ordinate. Second element is called ordinate. Abscissa and ordinate. The combination of a pair of elements we are arranging in a manner such that x comma y, where x is called abscissa and y is called ordinate, where these x and y can be taken from two different sets. X belongs to capital A and y belongs to capital B. Okay, na? X belongs to capital A and y belongs to capital B. Now let us discuss about the Cartesian product. For example, there are two sets, nothing but A and B. There are two sets, nothing Cartesian product. Cartesian product. Okay. There are two sets, nothing but A and B. The A and B we are writing in a manner that is A cross B. We should read it as A cross B or A into B. A cross B having an element such that like order pairs. Cartesian product having a elements like ordered pairs. This is a set which are having elements like ordered pairs such that x belongs to capital A, first one, and y belongs to capital B. Okay. In the same manner, I am taking like B cross A. B cross A, I am writing like A comma B. A comma B, such that first letter A belongs to first set B, second letter B belongs to second letter A, in a such a manner. So this type of product is called Cartesian product. How many? Cartesian product. To find the, to write or to express any two sets are in the form of Cartesian product, the two sets cannot be empty sets. So A and B cannot be empty sets. Empty sets are nothing but null set. There is no element in that set, that is called empty set. Okay, na? So that means A and B must be finite set. A and B must be finite set. That means there must be some numbers in the both of the sets. Okay. So A cross B such that A belongs to capital A, B belongs to capital B. And the number of elements. So we are finding the number of elements. Let me take an example. For example, I'm taking like example A. Set A is having elements like 1, 2, 3, 4, and set B is having elements like A, B, C. Then while writing about the A cross B, writing all the order pairs. With 1, I am writing like 1 comma A, 1 comma B, 1 comma C. Next, second element 2, 2 comma A, 2 comma B, 2 comma C. Third element 3, with 3, 3 comma A, 3 comma B, 3 comma C. And the fourth element 4 comma A, 4 comma B, 4 comma C. So these are all the elements from the Cartesian product A cross B. There are how many elements are there? 1, 2, 3, 4, 5, 6. So 6 plus 6, there are 12 elements. So therefore number of elements in A cross B. N of A cross B is nothing but number of elements in the set A cross B. That is nothing but 4 into 3, 12. Nothing but N of A into N of B. Simply we can write N of A into N of B. Number of elements in set A are 4. Number of elements in set B are 3. 4 into 3. There are total 12 number of ordered pairs in the Cartesian product A cross B. Okay, na? So this is about the Cartesian product. You know how we are writing it. Always the first element represents the first set. Second element represents the second set or belongs to the second set. Okay. Now coming to the relation. Relation is nothing but every subset of A cross B is a relation. Is called a relation. So relation is nothing but every subset of A cross B is called its relation. For example, let me write some. For example, I am taking element like A1, 2, 3. There are 3 elements. If you wanted to write some subsets for this, I can write only 1, only 2 as a set, only 3 as a set, only 1 comma 2 as a set, 1 comma 3 as a set, 2 comma 3 as a set, and 1, 2, 3 as a set. So 1, 2, 3, 4, 5, 6, 7. See, these many subsets are having by set A and also 5. 5 is nothing but empty set. Empty set means there is no element in a set is called empty set. Empty set is always a subset of every set. Okay, total 8 are there. Now here also, relation is nothing but every subset of a Cartesian product is called its relation from A to B. Okay, na? Then number of relations, very very important. Number of relations formula. Number of relations is equal to N of B whole to the power of N of A. N of B whole to the power of N of A. Am I right? Sorry. Number of relations formula is 2 to the power of N of A into N of B. Okay, na? For example, A is having number of elements in A is having M. Number of elements in B is called N. Then total number of relations is 2 power M into N. 2 power Mn. 2 power Mn relations will be there. Let me take one example. For example, the set P is having the elements like A, B, C, and Q is having the elements like 1, 2, 3, 4, 5. Then number of relations formula. Number of relations is equals to 2 power N of P into N of Q. N of P is nothing but number of elements from set P. N of Q is nothing but number of elements in set Q. Let me write that is 2 power N of P. Number of elements in set P is 3 into Q. Number of elements in set Q is 5. So 2 power 3 into 5 is 15. 2 power 15 number of relations will be available between P and Q. Okay, na? Right. Now let us discuss about the function. Function is nothing but extended form of a relation is called function simply. Extended form of a relation is called function. Let me take the brief explanation of the function is nothing but a relation from set A. F is a relation from set A to B. Let me discuss about function. Like set A and set B are there. It is having some elements, set B also having some elements. From A to B, there is a relation F. Okay, na? So a relation F from A to B is said to be a function, or it can be called a mapping also. We can call F is a function, or F is a mapping, and F is a correspondence also. When it is possible means each and every element of set A, because we are writing that F is a function from A to B. I am writing that F is a function from A to B, set A to set B. Then when it is become a function, because there is each and every element in set A, there exists a unique element in set B. How it is belongs to? For example, A is an element in set B. Here are some elements in set A. A is element in set A, B is some elements in set B. Every element from set A, every element from set A must be mapping with there exist unique element in set B. Unique element in set B. Then only we can say that F is a function from A to B. Let me take an example like F is a function from A to B. I am taking like 1, 2, 3, 4. Here A, B, C. 1 is connecting with A. Okay, na? For every element of A, there must be exist element in B. So for 1 there is an exist element is A. For 2 there is an exist element is B. For 3 there is exist element of A, and 4 exist element of C. One unique element. So 1 is having only one element in B. 2 is also having one element in B. 3 is also having one element in B. 4 is also having one element in B. Only one element must be there. Okay, na? So here while you are observing here set A and set B, here set A is called domain. Set A is called domain and set B is called codomain. Set A is called domain, set B is called codomain, and the A is called image of 1. Here A is called images. That means the elements in codomain are called images. Elements in codomain, I am writing here. So elements in codomain are called images. Same way, elements in domain are called pre-images. Images and pre-images. So simply for writing this one, there is a function, right? So this one I can express in a form of like, so this is 1, f of 1 is equals to A. F of 1 is equals to A. F of 2 is connected to, what is the image of 2? Image of 2 is B. So f of 2 is equals to B. And f of 3 is equals to A. And f of 4 is equals to C. So here f of 1, f of 2, f of 3, f of 4 are called images. Okay, na? Images of 1, 2, 3, 4 respectively. Clear? So we have discussed about the function, nothing but it is an extended form of a relations is called function. Simply we can take, if you are having any two sets like A and B, F is called function from A and B, only there exist all the elements of set A having unique element in set B. Okay, that means simply all the elements from set A having an images, their images in set B are called function. Such type of elements are available in these two sets are called functions. Okay. Right. Now here are some note points we have to discuss about it. That is, every function is a relation. We have discussed the formula for number of relations from A to B, nothing but 2 power n of A into n of B, total number of relations from set A to set B. And here if you are taking that all the functions can be relations, but all the relations cannot be a function. That means its converse statement can be false. Its converse statement can be false. Clear? Yes. So we can write this one as, all functions can be relations, but all relations cannot be functions. But all relations cannot be functions. Okay. Okay, let me take one example that cannot be a function. For example, I am taking two sets like A and B. F is a function from A to B. F is a function from A to B, and there are some elements in A are nothing but 1, 2, 3, 4, and the elements of B like A, B, C, and 1 is mapping to A, and 2 is mapping to B, and 3 is mapping to C. So there is no element, there is no image for 4. There is no image for 4 in set B. So we can take this one as, we can say this one as, it is not a function. It is not a function, because according to the statement or the definition of a function, we have decided or we have discussed that every element in set A must have the image, unique image. Must have unique image. Then only we can say that F is a function from A to B. In case if there is a element remains like this empty without any images, such type of relations or mappings, we can say that is not a function. Okay. Now number of functions, like number of relations formula, we have discussed that 2 power n of A into n of B, nothing but number of elements in set A into number of elements in set B. Same way, number of functions formula. Number of functions from A to B is nothing but number of elements in B whole to the power of number of elements in A. For example, here, how many elements are there? For example, I am taking like set A and set B here. F is a function from A to B. Here A, B, C, 3 elements in set A, 2, 3, 2 elements in set B. A mapping to 2, B mapping to 2, C is mapping to 3. So it is a function because every element in set A having an image. Every element in set A having an image in set B. So it is a function. So according to this, how many elements, number of elements in set A are 3, number of elements in set B is 2. Therefore total number of images is 2 power n of B means number of elements in set B whole to the power of number of elements in set A. That is 2 power 3, nothing but 8. There are 8 functions we can write. Okay, right. Now, and we have already discussed about domain and codomain, right? Elements in domain and elements in codomain. So elements in codomain are called images. Elements in codomain are called images. Okay. So let us go to the concept based questions. And still we have about a period in a functions, period of functions we need to discuss. So let us discuss it later. What about the greatest integer function? I think we have discussed in our previous classes what is the greatest integer function. So greatest integer of x is nothing but x minus greatest integer of x. For example, x is a number like 2.25. The greatest integer, x value if you take 2.25, the greatest integer of x is nothing but 2. So 2.25 is nothing but it is exactly lies between 2 and 3, and the smallest value nearer to 2 and 3 is nothing but 2.25 is nothing but 2. Smallest value we should take, that is called greatest integer function. Same way least integer function for 2.25, least integer function will be 3. Okay, right. Yeah. Now let us try to discuss about concept based questions from practice sheet 1. Let us see. Concept based questions. So first question. So that is given that, so A cross B is given about A cross B. A cross B is nothing but a Cartesian product. A and B are two sets. They are in the form of A comma B. Thus two sets, the A cross B is in the form of set of ordered pairs. Set of ordered pairs. Or we can take it as A comma B or X comma Y, or wish. A cross B are nothing but set of ordered pairs are in the form of X comma Y, where X belongs to capital A and Y belongs to capital B. So this is called A cross B. So according to the four options, first option will be our required answer. Let us move on to the question number 2. Okay. So that is given that if set A containing the elements 1, 2, 3, 4, A is having an elements like 1, 2, 3, 4, and set B is having elements like A, B, C. Set B is having elements like A, B, C. Next, then which of the following are functions? Which of the following are functions? So according to the four options, let us go through the options first. Then only we can identify which is exactly the function. So let me go through the first option is, the first option is given that set of 1 comma A, 1 comma A, and second one 2 comma B, third 3 comma C, and fourth one 4 comma A. Okay, option number 2. The second option is given 1A, 2C, 3C. 1A, 2C and 3C. Next, option number 3, that is 1A, 2A, 3A, 4A. 1A, 2A, 3A and 4A. At last, both 1 and 3. Okay, let us discuss it. Now I am taking two sets like A and B. A and B. F is a function from A to B. So A is having the elements like 1, 2, 3, 4. B is having the elements like A, B, C. And the first one is given the ordered pairs like 1 to A. So 1 to A mapping is given. So 2 to B mapping, 3 to C mapping, and 4 to A mapping. So first point we need to check that the elements, all the elements in set A are connected to at least one element, unique element in set B or not. Yes, 1 is connected to A. 1 is having an image. Very good. 2 is also having an image. 3 is also having an image. 4 is also having an image. Yes, obviously set 1. That means option 1 can be the function. Let us go to the option 2. Option 2, before that, the sets A is containing the elements 1, 2, 3. B is containing the elements A, B, C. So F maps from A to B. Now the options are given here 1A, 2C, 3C. So 1 to A is mapping, 2 to C is mapping, 3 to C also mapping. So 1 is having an image, 2 is also having an image, 3 is also having an image, but 4 is not having any image. So from first set, that means the elements in domain should have particular image, or else it is not a function. Or else it is not a function. Okay. So second option cannot be the function. We can eliminate this one. Now coming to the third one. So 1, 2, 3, 4. All the elements in A, all the 4 elements in having the same image, all are connecting with A. We can take it as a function because according to the definition we must have image. That's it. But the same image or different images are not mentioned here. So only the image is there or not from the all the elements of domain or not is very, very important. So according to the definition, the third one also the correct. So first one and third one, both the options are true. So we can go through the fourth option. The fourth option is given both 1 and 3 is correct. Fourth option is given that both 1 and 3 are correct. So we choose the option 4. Right. So let us move on to the question number 3. Okay. So that is given that number of elements, if number of elements of A is m, n of A is equals to m, and number of elements in B is n, n of B is equals to n. Therefore, the number of relations from A to B. We have already discussed the formula for number of relations is equals to 2 power n of A into n of B. So 2 power n of A value m, n of B value n, that is equal to 2 power mn. Total number of relations from A to B, or number of relations from A to B. Okay, right. So move on to the question number 4. Same, n of A is equals to m, number of elements in set A is m, number of elements in set B m, n, then function, number of functions. What is number of functions formula? Number of elements in codomain whole to the power of number of elements in domain. Number of elements in codomain are given that n, and number of elements in domain is m. So simply number of functions are n to the power of m. N to the power of m. So let us move on to the question number 5. Okay. The fifth question is given that if f of x equals to x plus 2, f of x, the function f of x is equals to x plus 2, and g of x equals to x, g of x equals to x, and h of x, h is also a function that is nothing but x square. There are three different functions, or three functions from the same sets like a, b, c, like that. Okay, so f of x, g of x, and h of x. Now coming to here, the question is asking about if where f, g, h are real functions. F is a function from the set of real numbers, g is a function from the set of real numbers, and h also the function from the set of real numbers. Then we need to find out h circle, g circle, f of x. H circle, g circle, f of x. Let us try to find it carefully. Now h circle, let us find g circle f of x value. This one, g circle f of x. Yeah, I am going to find out here. So g circle f of x, we can write according to g of f of x. Circle means of. Okay, na? G of f of x. That means g of, what is the value of f of x? F of x value is x plus 2. F of x value is x plus 2. Now, it is in the form of g of x. But g of x value how much? G of x value is x. That means in the place of x, we are having x plus 2. Therefore, g of x plus 2 is nothing but x plus 2. Now, identify the entire answer. So, h of g of f of x, this one. G of f of x value we got x plus 2. Now, h of x, it is in the form of h of x. H of x value x square. So, in the place of x, we are having x plus 2. So, it is nothing but x plus 2 whole square. So, while you are observing the algebraic identity, it is in the form of a plus b whole square format. Nothing but a square plus b square plus 2ab. A square plus b square plus 2ab. Nothing but x square plus 4x plus 4. This is the value of h circle, g circle, f of x. Option 4 is our required answer. Let us move on to the question number 6. Yeah. Again, f of x value is given, but this time f of x value is in the form of fractional, nothing but x plus 1 by x minus 1. F of x value is given like x plus 1 by x minus 1. Now we need to find out the value of f circle, f of x. Okay. Now this is, I am going to write f circle or f of x like this. Am I right? F circle f of x. Now this one f circle f, this f of x value is nothing but x plus 1 by x minus 1. Okay, na? Again f circle This is also in the form of f of x. F of x formula what? F of x formula x plus 1 by x minus 1. So wherever you see the x, we have to substitute this one. X plus 1 by x minus 1. So in the place of x, I substitute entire this fraction plus 1 by x minus 1. X means again x plus 1 by x minus 1 minus 1. That is equals to f of, try to simplify this one. It is in the form of x plus 1 plus 1 into x minus 1 is nothing but x minus 1 whole divided by x minus 1, nothing but LCM. Now here also x plus 1 minus 1 into x minus 1 is nothing but minus x plus 1 divided by x minus 1. So both the denominators are same, we can cancel it here. That is equals to f of plus 1 minus 1 cancel, the answer is 2x in the numerator, and plus x minus x is cancelled, the answer is 2 in the denominator. So 2 cancel, finally we got again f of x value is nothing but x plus 1 by x minus 1. F of x value again nothing but x plus 1 by x minus 1. So option 2, this is nothing but f of x. Right. So let us move on to the question number 7. Yes. The 7th problem is given that the even function among the following. So we need to discuss about the even function and odd function. What is an even function and what is an odd function? For example, f of x is a function. F of x is a function. If you write in the place of x as minus x, f of minus x value and f of x value both are same. That means f of x equals to f of minus x. That is called even function. F of x value and f of minus x value both are equal. We can consider that is an even function. But coming to the odd function, f of x equals to minus of f of minus x. This is the statement of odd function. That is the statement of odd function. Now let us go through the options one by one. The first one is f of x equals to, the first option is f of x equals to x to the power of 4 plus 3x plus 2. X to the power of 4 plus 3x plus 2. And second option is f of x equals to x to the power of 4 plus x square plus 1. Third one, f of x equals to x cube plus x minus 1. X cube plus x minus 1. Sorry, x minus 2. And the fourth option is f of x is equal to 2x plus 3. F of x is equals to 2x plus 3. Now in the place of x, let us try to substitute minus x in each and every option. Let us go through it. F of minus x value, check here. So minus x to the power of 4. Whenever you are having the even power, the negative x also converted into the positive manner. So it can be x to the power of 4. But here 3 of x can be minus 3x. 3 into minus x is nothing but minus 3x plus 2. Okay, na? Next, coming to the, that means f of x value, f of minus x value both are same or different. X to the power of 4 plus 3x plus 2 and x to the power of 4 3x minus 2, sorry, minus 3x plus 2 both are not same. So we can say this is an odd function, not an even function. Now coming to here, f of minus x. So minus x to the power of 4 plus minus x whole square plus 1. Minus x whole to the power of 4 is nothing but x to the power of 4. Minus x whole to the power of 2 is nothing but x square plus 1. So after simplification, f of x value, f of minus x value both are same. So it is an even function. Coming to the third option, minus x whole cube plus minus x minus 2. So minus x whole cube is nothing but minus x cube. Now here plus into minus, minus x minus 2. So f of x, f of minus x are different. So it is an odd function. Now last one, f of minus x value, that is 2 into minus x plus 3. 2 into minus x is nothing but minus 2x plus 3. 2x plus 3 minus 2x plus 3 both are different, so it is an odd function. Among the 4 options, only option 2 is providing us as an even function. So according to the question, the even function is option 2. Okay, let us move on to the problem number 8. Right, eighth question. The period of secant square x minus tan square x. So we need to discuss about the period concept once. Let us discuss here. So we know already the trigonometric ratios. There are 6 different type of ratios are nothing but sin x, cos x, tan, cosecant, secant and cot. Cosecant x, secant x and cot x. Okay, na? So these 6 ratios are in the form of sin x to the power of n. That means sin square x, sin power 4x, sin power 5x. That means this power n can be any natural number if you can take. All are in the form of same powers like this. Sin power nx, cos power nx, tan power nx, like cosecant power nx, secant power nx and cot power nx. If these are in this form, they are having the period of pi. That means the range of the trigonometric ratios are between 0 to pi. Pi is nothing but 180 degrees. Okay, na? So it can be possible only if n is even. If n is even, the period is up to the value of pi. Now coming to the tan power x and cot power x. Okay, this is for only the first 4. That means 1, 2 and 4, 5. See, sin, cos and cosecant and secant. Sin and cos and their reciprocals, cosecant and secant having the value of pi, and remaining tan and cot having the period as 2 pi. Okay. Now coming to all the trigonometric ratios, if even or odd, but they are in the form of sin power, they are not in the form of sin power nx and cos power nx like that. Only the single ratios are given. This one having the period of between the sin to cos is pi. Whether n value can be even or odd, it doesn't matter. Okay, next, greatest integer function, like x minus greatest integer function of period is always 1. Okay, na? Greatest integer function period is always 1. Next, algebraic function does not have any periods. So remember that one. So according to the 8th problem, secant square x minus tan square x value, where squares are even numbers. So even numbers we can treat as pi is a period. Okay, na? So second option. Let us go through the last problem here. 9th question that is given that. So f of x is in the form of ax cube plus bx plus c. F of x is a function which is in the form of ax cube plus bx plus c, which is nothing but algebraic function because they are in the form of letters and in the form of cubic polynomial. So it can be an algebraic expression. Then c can be, what is the value of c? What is the value of c to become a function is odd function? To become this function is odd function, the value of c must be 0 according to the concept. If the constant values become 0, this function can be an odd function. Okay, so that's it for today, children. Thank you and all. Have a nice day. Bye bye.